Alright, so in this video we're going to talk about relative extrema and their signals. So we'll start with the definition. So a point A, f of A, is a relative, also called local, maximum point if there is an interval around A where f of x is less than or equal to f of A for all the x in that interval. All right, let's do a picture and explain what I mean here with a picture. So let's say we have a function f of x, and I will identify the local or relative maximum. So we have a relative maximum here, call it A, and here we'll call it A2. So the reason that these are relative or local maximums is there are intervals around the x values, the a's, such that if you take any x in this interval, the output at x is less than the output at a. So these are both relative maximums by definition. Okay, so we can define relative minimum in a very similar fashion. So for relative minimums, we're going to just replace the less than or equal to with greater than or equal to. That's this inequality here. Okay, so the relative minimums in this picture are here and here. Relative minimums. Okay, and more conceptually, relative maximums are peaks in the graph. Peaks in the graph. And relative minimums are valleys. All right, so let's do an example where we analyze a function and find its relative maxes and mins. Before we do this example, though, let me not get ahead of myself. Let me make a note. So here's my note. So note that at the places where f of x has a relative max or min, also called relative extrema, the derivative at those values is equal to 0 or is undefined. Okay, so going back to our picture, the red dots and the purple dots, either the derivative is 0, slope is 0, or it's undefined. And here we have a cusp. In this last point, we have a cusp. Okay, so these places where the derivative is 0 or undefined, these are called critical points. Okay, so this is a signal for potential relative max or min. All right, now we can do our example. Well, it's example 1. So let's consider the function x times x minus 1 times x plus 1 and identify locations of relative max or min. So let me first graph the function. So it has a 0 at -1, a 0 at +1, and a 0 at 0. So here's our function, f of x. If I expanded the formula here, I get x times x minus 1 times x plus 1, which is x squared minus 1. So f of x can be written as x cubed minus x. So let's now take the derivative and set it equal to 0. The derivative is, by the power rule, 3x squared minus 1. Set that equal to 0 and try to find x. So we'll get 3x squared equals 1, or x squared equals 1/3, or x equals plus or minus the square root of 1/3. So that negative square root of 1/3 value is going to be corresponding to our relative max, and the positive square root of 1/3 is corresponding to our relative min. Let me write it over here. So our relative min is positive square root of 1/3, f of square root of 1/3, and our relative max is negative square root of 1/3, f of negative square root of 1/3. Okay, so you could evaluate the function at square root of 1/3, but I'm not going to. All right, let's do another example. Call this example 2. So in this example, I want to find the places where the function has a derivative of 0. And then I'm going to use the graph to identify the relative extrema. Okay, and our function is x to the 4th minus 4x cubed plus 1. So let me start by drawing our function here. Okay, so the function passes through here, 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 and here. So it looks something like this. Okay, so now let's take the derivative. We'll get 4x cubed minus 12x squared. We could factor out the x squared. The 4 and the x squared will get x minus 3 times 4x squared. If we set this derivative equal to 0, we'll get x equals 0 and x equals 3. Okay, and that corresponds to this point here. You can see the derivative is 0 there, and this point over here, the derivative is 0 there. So 3, f of 3, by looking at the graph, is a local or relative minimum. So here's our point 3, f of 3. I think f of 3 is negative 26. So you could write negative 26, or you could write f of 3. And 0 f of 0 is neither a relative min or a relative max. All right, I hope you found this video useful.